Hello, everyone. Today we get to talk about one of my favorite topics and something that a lot of people don't use. But in my line of field, I use it quite a bit. So today we are going to talk about logical reasoning. And it's very surprising when you enter the workforce one day, you'll see that there's a lot of illogical reasoning, and it's quite shocking, to be honest. But we are surrounded by it daily, and so you're going to learn some stuff today in logical reasoning that will help you do your jobs better and be a better asset to others. So there's two goals today. One is to identify the hypothesis and conclusion in a conditional statement. And the second goal is to use a counterexample to show that an assertion is true. All right, so let's dive on in. Let's look at the definition. Well, not so much of a definition, but what is a conditional statement? So if A, then B. You're like, what on earth does this mean? So if A, this is the hypothesis. So basically what we're saying is, if so-and-so is true, if A is true, if John goes to the market, that's the hypothesis. Then B, this is the conclusion. So basically, if the hypothesis is true, then the conclusion happens. This is what we conclude. So we make some guess about something, we make some prediction, and if that comes true, then the conclusion happens. All right, so let's look at an example. Let's identify the hypothesis and conclusion. Get a little funky here. Conclusion. All right. And let's kind of split this into multiple parts. Let's say if it is Saturday, Sandkat and Animesh go to play cricket. Okay? So which part of this statement is the hypothesis? So the hypothesis is if it is Saturday. So if it's Saturday, then something else becomes true. And what is the conclusion? Well, if it is Saturday, the conclusion is that Sanket and Animesh go to play cricket. Okay? All right. Let's look at another example. And that was a horrible B. Let's look at one in algebra. If x plus 3 is greater than 7, then x is greater than 4. Okay, so what would be the hypothesis here? Well, if x plus 3 is greater than 7, that's the hypothesis. So if this is true, then something happens. And then what's the conclusion? If x plus 3 is greater than 7, then what happens? Then x is greater than 4. So this is the conclusion. Okay? And this is the hypothesis. All right. Now, I noticed this went in a certain order. We always had the hypothesis first and the conclusion last. That doesn't always happen. Let's try to find an example where this is the case. So let's say I will go to church with you on Sunday. Alright, so what is the part of the conditional statement here that would be the hypothesis? What does it have to be for something to happen? It has to be Sunday, right? Before I will go to church with you. Okay? So Sunday would be the hypothesis. I will go to church with you would be the conclusion. Let's look at another one here. For any number 12y minus 40 equal to minus 28, y equals 1. Alright, so what would be the hypothesis here? Let's let you guess. You tell me. If you said for any number 12y minus 40 is equal to minus 28, you're right. That would be the hypothesis. And what would be the conclusion? What happens if this is the case? Y is equal to 1. You're right. Alright, let's look at another definition. Let's look at deductive reasoning. This is the process of utilizing facts, rules, definitions, or properties to reach a valid conclusion. Wow. So this is used quite regularly in my field, and to be honest, a lot of people in the world don't use deductive reasoning. They could care less about facts. Sometimes people make decisions and operate off of opinions. Sometimes people don't really care what rules are. There's times people don't even care what definitions are or properties. And they don't care if their conclusion is valid. Sometimes they're okay if it's invalid. This is very bizarre to me from my perspective to think this way. But there's a lot of people that do this, and I see this quite regularly. But here in this subject, we want to use deductive reasoning. Okay, let's look at an example. Alright, we want to determine a valid conclusion that follows. Getting a little sloppy here. Let's try again. That follows from the statement if two numbers are odd, then their sum is even for the given conditions. So if this is possible, we want to determine if there's a valid conclusion. All right. So let's look at part A. The two numbers are 3 and 7. So 3 and 7. Are these two numbers odd? Yes, they are odd. And 3 plus 7 equals 10. Is that even? Yes. So this is a true statement, and the conclusion is that the sum of 3 and 7 is even. Okay, let's look at part B here. All right, the sum of two numbers is 14. All right, so let's look at a couple numbers here. Let's pick what's the first couple numbers, first and end numbers to add up to 14. Let's say 1 and 13. 1 is odd and 13 are odd. So the odd, that passes, and this equals 14, so that passes. Okay, but it didn't say it was 1 and 13, it just said it was sum of two numbers is 14. So let's try two more numbers. Let's try 2 plus 12. Are these odd? No, these are not odd, but they are equal to 14, so they only pass one of the two. So it depends on what the numbers are, whether this is true or not. Some numbers this is true, and some numbers it is not true. So this leads us to another definition. Let's talk about counterexample. This is a specific case in which a statement is false. So right here we found a case when it is false, right? In this case it was true, but in this case it was not true. All right, let's look at an example. If you are driving a car, you have a driver's license. All right. Now, what would be a counterexample to this? Does it have one? I think so. I think you could drive a car with a, if I can write, a learner's permit. Okay, that's a counterexample. You don't have to necessarily have to have a driver's license to drive a car. You can drive a car if you have a learner's permit. All right, let's look at some problems. All right, so we want to identify the hypothesis and conclusion of the statement, then write the statement in if-then form. So in the case of the conditional statement, if-then, if A, then B. Okay, so we have a rectangle is a quadrilateral with 4 right angles. All right, so let's identify the conclusion, or hypothesis, sorry. The hypothesis is a quadrilateral with 4 right angles. If that is true, then the conclusion is that it's a rectangle. So let's write it in a if-then statement. If a quadrilateral with let's see, if a quadrilateral has 4 right angles, then, so this is the if-then. We have an if and we have a then. If this is true, then it is a rectangle. All right, let's look at one more example and then we'll call it a day. Or another problem here. So we want to do the same steps. We have another sentence here. A triangle with all sides congruent. Is an equilateral triangle. All right. So what would be the hypothesis? If there's a triangle with all sides congruent, that would be the hypothesis. So then what would be the conclusion? It's an equilateral triangle. All right, so let's write this in if-then form. If a triangle has all sides congruent, then it is an equilateral, if I can spell, triangle. All right, great job. So that ends our lesson on logical reasoning, and I hope that you will use logical reasoning specifically if you go into some type of science field where it's used heavily. If you liked, please click the like button and please subscribe if you haven't already. I will see you guys in the next lesson.